All right, next up, we have a panel that's titled From Potential to Practice, Quantum and AI on the Path to Adoption. Our speakers are going to be Jonathan Savoy, CEO at Quincus, Dr. Elvira Shashinana, Senior Director of Strategic Initiatives at Continuum, Martin Yates, Government Technology Advisor at Presight, G42, and moderated by our fearless leader, Malik Trebelsilob, CEO at Vernwell Group. Get the furniture up here. Worth noting, people see that the Nobel Prize in Physics went to John Martinez and two other quantum physicists for quantum tunneling. It was announced, I think, on Monday. So quantum in the news, pretty cool.
Destin? Yes. Good afternoon again. I'm still standing up. So far, it's okay. So thank you for joining us, and thank you for staying here up to the end of the day. I think it's very interesting. I've done a lot of conferences before, but to have people speak about specific industry like the maritime is quite interesting. And I did not see that before, not because we are a part of the project, but really it's very, very interesting. One of the most interesting technologies for me as a subset of the quantum technologies is quantum sensing. And it was really interesting presentation, even though I came a little bit later, but it was really, really good. And this is what is about the value that the quantum technologies can bring. Probably what is being able to be adopted before the other quantum, the subset of the quantum technologies. Like for so many people, they think that quantum technologies is quantum computing only, and that's what we try our best in order to make this awareness, especially for leaders and board members, to understand that it's more than that, and we need to look at it. The other point that we see always is we speak about AI so often, and then, okay, there's quantum, and we should look at quantum and AI together, and that's what is this panel about, and we have amazing panelists. And one of our panelists, he is working on AI every day in port operations. So Jonathan Savoy, the co-founder and CEO of Quincus. We are joined also by Dr. Elvira Shashanina. She was with us this morning, good friend of mine. So she's a senior director of strategic initiatives from Continuum. And Martin Yates, if you came to the Quantum Innovation Summits, you would have seen both of them, Dr. Shinanina and Martin Yates. He is a government technology advisor at Presight. If you are familiar about G42, I think you are. Anyone doesn't know G42? I think everyone does. Yes, exactly. So I would like to give you the floor to introduce yourself. Probably it's better than I do.
Thank you, and thank you for having us. So I'm Jonathan Savoy. I am the CEO of a company called Quincus. We run supply chain technologies, primarily focusing on two components. One is digital twin, and really mimicking a full supply chain, complex technology supply chains, whether it's for, and I've heard a bunch of aircraft manufacturers today. One is aircraft manufacturing, oil and gas, shipping liners, so it's across the board. And then secondly, underneath that is really building out machine learning technologies, and more modernly named as artificial intelligence technologies, to optimize these supply chains.
Thank you very much, and welcome. Elvira.
Thank you so much, Malik, for inviting me to be a part of this amazing panel. So I'm Elvira, working for Quantinum as a Director of Strategic Initiatives. We're building quantum computing full-stack solutions, starting from hardware, middleware, and software applications, and present in the 6 countries in the world. With more than 600 people, mainly researchers, working for us. So happy to be here and share our point of view regarding the development of the tech and specifically computing in the future.
Thank you for being with us. Martin, the floor is yours.
Okay. Right, good that nobody said they didn't know G42, so that's a good start. But I do, I'm Martin Yates, I'm from a group called Presight, which is a member group of the G42 group. So within the G42 group, we have various different business divisions and technology divisions. So, you know, ones that are very, I would say high level, like Space 42, so geospatial satellite launches, etc. We have data center builders such as Kazna, so you would have all heard of Stargate, UAE. I guess that's another question, is it, where someone says, I've never heard of Stargate or something. So you know, that's sort of rapidly being sort of built and being created amongst our group, as well as, you know, various healthcare groups and technology advances and, you know, our AI data centers from Core 42. So a huge amounts happening in AI. We're going to get a big electricity bill this year, I think, with the number of things that we're building. In Presight myself, as government technology advisor, I tend to sort of look at the big picture and say, where is the world moving to? Where does the business need to move to? And what might be the right kind of investment? So we're very much always looking for, you know, IP from around the world, new companies that we can invest, or mergers and acquisitions, joint ventures and partnerships. So we're very hungry for, you know, innovation to bring here and build and evolve within the UAE. So that's essentially what I do. Thank you.
Thank you for being with us. So you are one of those who are behind the scenes driver of the AI integration in the UAE, probably.
Yeah, that's probably it. Very behind the scenes. I sit in my office in the dark, yeah.
So I have a question from that vantage point, that sitting in your office in behind the scenes. And I would like to ask you, how are national strategies and enterprise priorities adapting to this convergence of advanced technologies, be it quantum and AI, for example?
Well, yeah, that's quite a big question, actually. So to sort of unpack it a bit, that you know, if we look at the national initiatives, you know, 2031 initiatives, AI, if we look at what the research establishments are doing, MBZ, UAI, the university that's completely dedicated to artificial intelligence. So the whole government itself is completely behind the development of artificial intelligence, smarter use of data, and in all of its use cases. And of course, you know, when we also look to TII as well, they've been doing a fantastic amounts of work on both quantum sensing and quantum computing as well. So the whole country is fully behind the development of artificial intelligence, as we mentioned earlier with Stargate. You know, we've had tremendous great investments with Microsoft to further drive artificial intelligence and quantum computing levels through the services that are provided by Microsoft for quantum. So that there really is a groundswell momentum in every area. Of course, AI leads first, and quantum is obviously following on the tails as it develops and evolves.
Okay. So I would like to ask Elvira, so Quantinuum leads different initiatives and global work at the intersection of AI and quantum computing. So the question is, how do you see this convergence evolving? And what early examples show these technologies are in their beginning, probably, of reinforcing each other?
Yeah, thanks for this question. I think I touched it previously a little bit during my presentation, so it's not a secret that classical AI can help us build better machines and better algorithms. It's already proven, it's already working, and we're actively using that. You see more and more trends right now in the market that quantum companies are acquiring AI businesses or pivoting themselves towards a little bit more AI, because naturally they come up to the idea that before this holy grail, fully fault-tolerant quantum computers with millions of logical qubits will come so that you can run those pure quantum simulations. Maybe you won't need the pure ones, but still, you will have to scale somehow with the smaller sizes. And that's why we naturally have to use the best of whatever we have, HPC, quantum AI, in order to mutually enhance those three technologies in the best possible way. And then we say in the best possible way, it's not the same when you come to people and say like, hey, tell me what you cannot solve with AI and I will give you a quantum solution. This doesn't work like that. Because usually if there is something like in the industrial company, maybe Abu Dhabi Ports group can help with that. If there is something that people cannot do computationally with AI in the industrial company, they most likely just don't do it, and they most likely just don't think about that. We need to identify the pure quantum phenomena or phenomena that will mimic quantum nature and apply quantum to that, and then use the generative AI layers, classical Gen AI, in order to build the design on top of that for future solutions. And this is how the only way we will be able to scale, at least in the near time.
Thank you, Elvira. So now I would like to ask Jonathan, because Jonathan already scaled AI and digital twin system across complex global supply. And if I would like to ask anyone about any advice or lesson learned or how you do it for quantum, I would come to Jonathan in order to ask him, because he's done it already with other sets of technology. So my question is, what lessons from these deployments that you have led can help organizations adopt quantum and AI more effectively, especially in the maritime sector? And whatever you're going to say, actually, it's a great advice for the rest who are working on this.
Well, I think let's start with don't do it. No, all jokes aside, obviously we're moving towards a world that is moving more efficiently, that is looking at optimization. And integrating artificial intelligence, integrating any type of platform is complex, especially in today's world where you're running into an organization and they have 200 different systems that are not talking to each other, and you have to pull data from half of them and consolidate data from the other half, and then somehow make up some kind of optimization solution for it. I think the key message here is start small. Really narrow down the problem to a single point where you can say, okay, this is going to take me a couple of weeks to maybe a month of development. It's going to give me an ROI that I can measure very quickly. And I think building that measurability is very important generally. For any business case, we talked a little bit about boards earlier, and that convincing a board is important. That is important, right? So there needs to be an ROI. And as you start small, then you can start scaling that up steadily and start expanding that. But that would apply to really artificial intelligence even more, because it is a data-intensive exercise, right? You need the data. And if you just try to gather all the data from every single system, then my team will affectionately call it, you're trying to build a global ocean boiler, which is probably true, right? And the way to mitigate that is pick very relevant use cases that are relevant to the business, immediate ROI, start small, and then scale up from there.
Thank you very much for this. And I would like to ask Elvira, is it what you do in Quantinuum? You start with small problems in order to, and start small?
But the question is, what you do, you boil the oceans. No, we don't. We are actually very energy efficient. We do, yes. This is the best what we can do right now, honestly. With the capacities that we have right now, we do build algorithmic primitives. And it all starts with the mathematics. We do identify the challenge. We try to identify the properties that mimics with quantum nature, because this is only there you can get this quantum advantage, nowhere else. And it doesn't make sense to squeeze anything into the quantum computer. It won't bring much. Once we identify those properties, we try to localize them and see how we can map them onto the circuit or onto the algorithms and do the small POCs, yes, or test those algorithmic building blocks. But it's not only about the algorithmic building blocks, it's also about the vision of the scalability. I would say that right now we have this luxury to have a roadmaps from the quantum providers, including in Quantino. We published recently one where you basically commit or recommit to a specific generations of quantum machines with specific properties, meaning that qubit counts, the fidelities, the speed clock, etc., that allow you on a very mathematical level estimate the sizes of the problems in a very conservative way, again, because it doesn't involve the possibility of discovery, but still estimate the problems and the systems that you will be able to run. So it's pretty much easy right now. It's not anymore pointing finger in the sky to see where we will be in 28, 29, 30, and 31. And again, bringing it to the business development teams within the industrial groups to see how it can actually impact their businesses and if it creates any value or not. The other side of that is also not only building the solution, but also foresee how the solution will be integrated through the actual pipeline. Because we don't imagine that being a startup or a quantum company, but the businesses or the pipelines or the tool chains we're building since ages in those organizations. It's a pretty much rigid systems. There are a lot of dependencies, so you cannot just take one piece of Lego and replace it with the other one. So if you want your solution to succeed and be adopted, you would need to think about that as well and work closely with the partners like Abu Dhabi Ports Group or Maritime or any other industrial groups.
Thank you very much. Now, my question to Martin, how do you see it from a government entities' perspective? Start small and build upon it. I know that in the UAE, when we start, we never start small. So how we do this?
Yeah, well, I guess when you're dealing at atomic level, it is starting small in a way, right? But yeah, and I do agree with what you say, that we tend to sort of do things big because we want results fast. And we are an economy and a country that's driven by, we need to be highly successful in everything that we do. Our vision is very clear. To be a world leader in many of these areas, and I think with the current agenda, there's every possibility that's certainly going to happen. In terms of how to bring the governments are already on board. We are looking at, of course, with the AI and the aspects of compliance and privacy and ethical use of AI. It's like, what are the frameworks that need to be wrapped around that? So we have a lot of focus on that. We have a lot of focus on the data. I would also say that, from our perspectives as well, that what must lead first above everything is perhaps the cybersecurity side of it, right? And we don't know when we're going to get enough logical qubits. I mean, certainly we have an abundance of physical, but logical is always a bit more harder to get to. So, already there is many guidelines on quantum safe computing, and that needs to be really enforced within civil defense, within the financial institutions. So already many years ago, I've been working with organizations how to become sort of quantum safe. And many of the organizations, the big names in the world, are already having very significant programs and investments on that. And to not invest in that side is also perhaps a little bit crazy, right? Because if you cannot protect your system in the future. So let's see what the roadmap looks like. I'm always ready for a kind of a black swan event, because we kind of have this kind of quantum roadmap right now where, well, we think it's going to be this many bits by this time, and this by this time, and this by this time. And, life has shown us so many times that just when we think everything is calm and normal, something comes along and disrupts it. So I'm kind of prepared for that too.
I hope the Black Swan event, it's not all in the sudden, we wake up in the morning and we hear that data from the banking system or something big happened because of all in the sudden we have heard an adversary has achieved a quantum, a cryptographically quantum computing, and then we know very well that there's no time to do any transition probably, or it's too late to prepare. So my question, because you talked about regulations and protecting data and everything, do you think we are prepared?
I
In
think,
general,
yeah,
I mean, I'm not going to speak about the specific.
well, if you look at all the work that's already happened, right, all the architectures being built, all the cybersecurity defense systems, I mean, you can never prepare for something that's impossible to even predict, right? But with all kind of rational sense and things that we see on roadmap, we're absolutely going in the right direction. You know, the right processes, procedures, the right technology, and architectures being created to defend against that. But of course, you know, no one and not anyone can say that someone can develop something in secret, right? And kind of change the game, as we talked about that Black Swan event. But we are preparing, and I say we collectively as with organizations across the UAE, and of course the government as well, as we've seen from the evidence of the frameworks and the work of the Cybersecurity Council. So absolutely, we are doing everything that is rationally and realistically possible to protect ourselves.
Thank you for that. So I go back to the AI and the adoption already. And of course, I would ask Jonathan for it. Where do you see AI already delivering a quantifiable value that could later be magnified to be used for quantum?
So I like to split up AI into two categories. One is assisting AI, which is your ChatGPTs in many ways, where you have a conversation, it assists you based on the data that it absorbs, but it won't really fully optimize. And for that, you have to go more into machine learning and what I would call optimization AI. And I think in both categories, they have a lot of applications. But when we think about, and I think the assisting AI is obvious. We're all daily interacting with it. The optimization AI is much more behind the scenes, right? But if you think about, let's say a DHL or a UPS or any global logistics provider, a lot of their systems, there is some component of AI that is driving an optimization. I saw a TSP problem being put up earlier. You know, there are machine learning methods that can solve it. And the issue is obviously it is an NP hard problem. Classical methods are hard to scale on that problem. And the combination of classical and AI can really solve those problems. Similar if you go into berthing scheduling, if we talk about ports, if you talk about network optimization, these problems are being solved. I think it was C.H. Robinson as a forwarder and operator that recently released, their CTO said, you know, they gained, I think it was 5% of their margin that they're attributing now on optimization through AI, right? So there are global leaders who are now leading with that, which is great. So in logistics, it is definitely happening. It is happening behind the scenes in many ways, but it is also a very far journey to go. I had a conversation with a partner in the last few days, and they're working on Excel, and they're working on pen and paper. And they're a global operator, right? So that also happens, and that's okay. I think it is a journey where we all have to move through. Unfortunately, logistics is very often seen as an older industry, which is often also true. But it is also an industry that is recognizing now that it needs to move forward. And look, the fact that we're here at a quantum maritime conference kind of speaks to that, right? We're at the forefront of technology at an industry that is realizing that they really do have to evolve. And there's a huge amount of super interesting problems to solve. I think it goes back to an earlier point we made, is relevance is important. It needs to be relevant. It needs to be specific. It needs to be a real problem to be solved. and make it as practical as possible with the real training that is needed for the people who are operating it at the end of the day.
You spent the half of almost the day here, and you talked to innovators from the quantum industry, and you also listened to some talks. Are you optimistic about the integration of the two technologies and using them as a force multiplier for to solve the problems that you face every day? Or maybe it took you some time to solve using AI.
Look, I don't think it's a question of if. I think it's a question of when. And I think I've heard 5 years, I've heard 10 years, I've heard 15 years today. So the time is a relevant question. But yes, quite frankly, artificial intelligence is helping building out more and more quantum compute and building out those algorithms. At the same time, I think it's going to be very true that quantum computing will accelerate artificial intelligence as well. I think they are symbiotic in many ways once they are integrated properly, and once we're able to build up the capacity and the compute for it. And this beautiful diagram that someone showed with probabilistic, quantum, classical, artificial intelligence, it's true, right? We do need to work in that realm of combining all of them to solve practical problems. One of them will not solve it on its own. Quantum is not going to solve the world. It's going to be a combination of all.
Elvira, you wanted to add something?
Yeah, absolutely. I'm fully agree with what you said. It's just, I can actually explain all those numbers, 5, 10, and 15, and they're all right. The question is, what do we mean under the solution, right? To beat classical exact FCI type of simulations for chemistry systems, you need to be able to run 100 active spin orbitals. So providers who will bring 100 logical qubits, which is on the maps of several, let's say, players in the market by the end of this decade, with very decent corrections and accuracies, will be able to do so. The algorithm exists right now. So would you get value for your company by running the systems with 100 active spin orbitals? Probably not, but it will be a true practical quantum advantage. Now, what value can you get out of those small systems? Again, those small systems, they are capturing some properties that are not accessible for quantum or for classical computers. Just feed them up into the generative AI and it will do the job to scale it up to the larger systems. And it was the same problem. I've been working in BMW previously, so I practically did the same job in BMW that I do right now for Quantinum. I tried to knock the doors of departments and convince them, hey, let's go quantum. And first time I came to the batteries department and I was like, this is so exciting. We can do so many things. And the first question they asked me, would you be able to run the surface reactions of 50 million atoms? And I was like, well, we would need like 100,000 of logical qubits, and then when you will be able, just come to us. So it takes a journey. It's a whole journey to come to people to understand what they are thinking for under the solution. What do they mean solution? What do they mean value? So maybe for those 100,000 logical qubits and these types of reactions, DVI and HPC combined, solution-ready product, it will take 15 years. But again, for this 100 active spin orbitals, I do believe, and I can bet my place in Quantinum right now, which is a good now, that we will get it by the end of this decade for sure.
No, I think I would, sorry. I think I would.
It's even better when there's an open talk like this.
No, 100%. I would agree. And I think it also depends, we started off the conversation with start small. I think that is the question, right? What is a solvable problem? Very often we're faced with problems that, involve 1 trillion nodes, and that's in a supply chain network, right? That's not uncommon. And you think that a node is just a port, right? No, a node is a potential vehicle, is a warehouse. It goes down to a container. It goes down to 1 trillion. And then quantum is nowhere near to solving that problem, right? And that's okay. There are other methods to getting near to an optimal solution. So it is a matter of perspective and starting small, right?
Exactly. So actually, I wanted to ask Martin, first of all, before my question, Stargate, quantum is involved or it's just AI?
Well, at the moment, what's actually published is I'd say the traditional. It's still a very modern approach, of course, with NVIDIA and the different chipsets. So it is the traditional, or however long traditional has been now, since AI has been with us quite some time. But the standard chipsets you would expect of NVIDIA, so for example. I'm not aware of any quantum in that space at this time. But you can be absolutely sure when you look to the interest of those chip companies, they will be including quantum, and they cannot afford to say, well, I'm not going to be in this game, right? Because they will want to, potentially create that as one of their hybrid architectures. So you'll see that over time, right? Today, the real focus is on the GPU, is get as much as you can out of it, reduce the power consumption, be smarter on the cooling. But quantum definitely will figure in many of their roadmaps, and if it's in their roadmaps, then it's going to come to our roadmaps too, and of course that then naturally would come to Stargate when it's decided appropriate.
Perfect. Thank you for answering that. And my question is about de-risking and adoption. And usually the problem with adoption of new technologies like quantum, it's the de-risking problem. And most of the companies, I'm not going to name, but big ones, they would say, no, we're not ready now. We are waiting to see and de-risk. So my question, how can public-private partnerships can help when it comes to advanced technologies like quantum, help into maybe put in the way of this first word that I see, which is we are waiting to de-risk. So how do you see this can happen using PPP?
Yeah, I mean, PPP is a very interesting model, right? And it varies from country to country. What's good in one place will be completely different model in another. In terms of, how to say, from a security perspective, government definitely needs to be there, and it needs to be in bringing in the private enterprise to be part of that journey. It's always like this, right? It cannot be left in the hands of government alone, and it cannot be left in, the hands from an investment perspective alone, because people, when they look to quantum, they get chills a bit, right? Because they look at, well, how long will it be before I get to those 100 qubits that my business says that they can do before I can do something useful? And that's even before you really get into the very, very serious numbers of qubits and what that can bring. So, yeah, absolutely. All countries, I think I pretty much looked at most modern ones, and they have a plan of how to build those models together. I've seen this already working well in Germany. I've seen this working in Canada. It's definitely going to be working here, as we've seen through the various different institutes. But it is a tough call. Someone to say, you need to put, millions and millions, perhaps billions on the table, and your return on investment might be 10 years from now. So my recommendation really is, you cannot afford not to invest, right? But perhaps the investment space should be in the education of quantum and what it brings. Look, we've got, hundreds of thousands of students all coming out. They've got a curriculum, they've got a course that's been very much tailored around the traditional approaches, generative AI now, of course. I think we need to double down on preparation as an investment in the people of the country as part of their future. And that's going to be, again, that they always say that, artificial intelligence will cut some jobs and will create jobs. And I think, quantum is going to be that space, but it's something that it's not tomorrow, but you have to prepare, absolutely.
Exactly. I would say something else when it comes to the risks of putting billions or millions and billions of dollars into systems that it's coming from cross-border. You know very well where I want to go is the tech transfer and the export control later on. So you paid all that money, you invest, and later on you have either the host country or the other where the technology is belong to which jurisdiction. And the problem, there is always a risk that something happen and there's export control is going to be cutting down the access to the systems. It's a possibility, no?
Yeah, I mean, the world is very fluid right now. Okay, it always has been, and it's nothing's different this time. So from export controls, and I can speak to here with the NUI, we have a very pragmatic approach. We build sovereign AI systems that are very contained and follow along the lines of government policies and regulations. So we build these sovereign clouds. We built the sovereign AI here that allows us to contain many of the risks that perhaps you spoke to.
There, where I wanted to reach is sovereignty is key. Exactly. So sovereign technologies is what we aim to achieve in order to have the advantage that any country would be looking after. So my last question I would ask, of course, forecast or future foresight always is important, but we don't know exactly. And Jonathan, he touched upon it. And some they say 5, and others 15, and we keep on going with any timeline of it. I just wanted to point out that I follow always the McKinsey monitor, quantum monitor, and they give you the charts and by the industry. And you see that the industry adoption, it would be very different from one to another. And it goes up to 2035, I believe, and more. So the question here, knowing all this, what is your future foresight about quantum and AI integration to have them into the operations of various industry, especially the maritime industry? Do you see it coming in the next future, or it's going to take more time? Is more than 5 years probably based on your idea? And based on your work, for example, Jonathan, you worked on AI for some time and you know how it takes.
I find it really hard to define the line where AI started and where AI started and where statistical methods ended. Whether it's 10 years, 15 years, some people say 5 years. It's hard to determine. What I do know is this, we are actively working on quantum use cases today. We're actively trying to narrow down very specific use cases that are enough that we say, okay, let's run a POC. Let's not spend $1 billion, but let's maybe spend some money so that we can actually see what the value is. And to your point, let's train a couple of engineers and see how they adopt it and go from there. And I think that is today. And that will tell us a lot in the next few years on how this can accelerate. If there's one thing that AI has taught us, and I think we have to attribute this to a handful of companies in the last few years, is 3 years ago, we would not have expected ChatGPT to be in our pocket. And I think that is what we have today. So.
Exactly. I just wanted to add that Kinkus is a partner with us in the challenge that we called to solve problems that Abu Dhabi Maritime Academy presented. And we have different teams. They are meeting tomorrow in order to meet the judges. And Jonathan is one of the judges who will be there also. So we are proud to be partnering together. So Elvira, I will ask you the same question. What is your idea about the future foresight of integrating these technologies together to see them really delivering value?
If I can touch a little bit the previous question to Martin about the export control and regulations. Obviously, this becomes to be a much more hotter topic because quantum progresses, computers become bigger and better. It can represent threat or value, and obviously governments, they want to have better control of that situations. We're faced to that personally not, but with Quantinuum, because we've been able to ship our machines abroad from the United States. The reason why people want to have machine in premises is because you have some critical data or use cases, either it's genomic data for healthcare or maybe some security data that you don't want to send over cloud to United States, but you want to keep them in a sovereign space and run the simulations locally. Right now, the situation is that we have to search that agreements with the United States, and fortunately, we've been able to do so. This is a great work of our lawyers, and I hope we will be able to continue to do so. It's a big question of diplomacy. How to protect ourselves in the future? Well, to bring the production to different countries. It's worth to say that it's not easy to bring production to different countries, because the reason our machines are exceptional, I like to say that, is because we have exceptional supply chain, right? And you don't have like thousands of companies that will be able to supply you with a perfect integrated photonics or lasers or all the optics that we would need to have. This is one thing. And this is also the reason why we are not selling much of computers right now, because people are quite aware that it's a first mover advantage. Even if we don't get value from machines, you can't imagine, but the demand is pretty high already now. The problem is that we're not able to produce them that much. And this is, again, not only the limitation of the supply chain that I mentioned before, also the limitation that you don't have hundreds of thousands perfect engineers or very strong engineers who will fabricate them. So it's a huge kind of puzzle piece with hardware, supply chain of enabling technologies. You have all this compilation, error correction, middleware part. You have the software development. You have education and the ecosystem. And again, going back to the point, you need to be able to properly identify the use cases that you want to solve. Not everything you can do with quantum. And for that, I strongly believe that the use cases that we discussed right now, they are motivated by our classical narrowed vision, and probably 90% of them won't actually be the use cases that we will be solving with quantum. So we need to work closely together to find those golden apps, I would say.
Thank you, thank you. Martin, what do you think?
I was just thinking about that, actually. Like, here's us trying to predict it, but when you think about that far ahead, we've already got, strong sort of statements saying superintelligence will be here, right? So perhaps superintelligence will decide on how to build quantum and how to use it. But one thing for sure is, it's going to be a slow burn adoption as the qubits increase of value. You'll see that those workloads being shared between traditional GPU and quantum. And I doubt if the human will have any interaction with that, because the AI will definitely within a few years be saying, I know what to do here.
I know better.
I know better than you do, right? Because I know all the systems. So, and I'm sure it will shop around for the best quantum of the day to get the job done, right, at the best price. So I think that's the bit we need to think about is, we all think of how transformational ChatGPT has been in just the last few years. But we haven't really seen anything yet. And I always say to people, it's amazing, it's amazing. I said, you know what? We're not even 1% in to the change that's coming. And people don't understand. I said, no, seriously, not even, you haven't considered robotics, you haven't considered the superintelligence, decisions being made for us, the right decisions for the world, the environment, transportation use cases. So I think, that's not the black swan, but that's kind of something that you need to factor in. We always think about as us humans looking into the crystal ball and deciding. I'm not sure it's going to be quite that way.
Exactly. I believe so also. I agree with you on that. And thank you so much for being with us, all of you. And please stay with us up to the end of the day, and do not leave before the last panel. Yes, and tomorrow it will be a full day also, and you will have the main room and the other one where you have tech tracks, and we'll be happy to see you again. Thank you.
Thank you. Thank you to the panel. So we're going to take a short coffee break, but before we do, I want to mention that after the short coffee break, we have a keynote speech from Dr. Emmett Oppmann talking from IBM. And we have a fireside chat talking about scaling quantum from proof of concept to deployment. So take 15 minutes, get some coffee,